ChatGPT is a
Windows 3.0 is
The internet starts as a military communication.
The Earth cannot sustain present population and industrial growth for much.
I start the machine running.
Unlike today, computers up to the early 1900s were single-purpose computers, or machines designed to perform one specific task. These pre-existing computers included clocks, calculators, and even human clerks. However, obviously, clocks could only tell time, and calculators could only calculate numbers. If you wanted to know the time and what was 1,348 multiplied by 435 in the 1920s, you had to use two different devices. Unlike nowadays, where you could just pull up your iPhone and do both of these things on a single device. This is the main gap between mechanical computers and digital computers, which took many mathematicians and centuries to cross. That was how computers were up till the 1900s. Their program was permanently engraved onto the device. The software and hardware was merged together, fixing the machine to only being able to perform one specific task. Although having fundamental limitations, mechanical computers were becoming more and more sophisticated. The jacquard loom, a weaving machine developed in the early 1800s that utilizes a series of punch cards to produce fabric. Similar to the modern terms of the binary system, its punch card operated on two patterns, a punched hole, akin to 1, and the absence of a hole, akin to 0, which each corresponded to different designs weaved onto the fabric. And in the 1820s, Charles Babbage, a mathematician and inventor, designed the difference engine, a mechanical calculator to tabulate polynomial functions. It was built for practical purposes, simply to calculate accurately every single time. However, the difference engine's complex internal construction was far beyond any pre-existing calculators. It had a storage, or a place where data could be placed temporarily for later processing, just like a modern computer. Just like the jacquard loom, it was on the verge of becoming the earliest computers. These mechanical devices were constantly getting more and more sophisticated, but were all limited to the rule of one device, one task. The NHD problem, posed by David Hilbert at the International Congress of Mathematicians in 1928, questioned if mechanical computers would eventually reach their limit in computability. In order to answer the NHD problem, the young Alan Turing mathematically proved the limits of mechanical computing with his paper, Uncomputable Numbers with an Application to the NHD Problem, published in 1936, introducing the idea that there are questions beyond the power of computer algorithms to answer. A mechanical computer would eventually reach a point where it is unable to compute anymore, even if it's supplied with an infinite amount of storage and time. To make a computer that wasn't bound to one program, Turing worked on an investigation, asking woman clerks, otherwise known as computers at the time, to note down each step in their thought process as they did their job. Whether it be to calculate the total profit of a business from the revenue, or bookkeeping, writing down records of past transactions, Turing studied the human thought process as they solved a problem. After working on his investigation for about a year until April 1936, Turing theorized that there could be a machine that would work just like a human brain. In 1936, Turing gave birth to the idea of the first modern computer, the Turing machine. The Turing machine was fundamentally built different from past mechanical computers. It was flexible, the device not bound to a single program, allowing it to be programmed and reprogrammed to do any kind of task, and it could hypothetically perform any computation without the limits of time or input. This is how the Turing machine worked. The Turing machine was made from lots of basic logic steps combined with conditional if-then statements that simulated the logical steps of a human clerk when solving a problem, information Turing had gathered in his investigation. Each logic step was like a Lego piece. allowing for vast amounts of combinations and enabling it to create any figure you want, with the ability of rearranging the pieces anytime. This gave the machine the ability to perform any task that can be programmed. Different to a mechanical computer, which was more like a hard plastic model, used for one purpose and unable to be broken into pieces and rearranged to perform other tasks. The Turing machine was the hypothetical model of the general-purpose computer, a single computer that has the capacity to carry out an infinite variety of tasks, or the digital computer, as we know of it today. In terms of its functionality, a simple picture of the Turing machine would be this. Think of a paper tape with coded numbers consisting of symbols zeros and ones that moves left and right. The machine's head would read this tape and react to these symbols based off pre-programmed instructions, or in Turing's words, the table of behavior, which, in modern terms, would be equivalent to a computer program. But what's so powerful about this concept? Through the process of finalizing his machine's design, he decided to propose an updated version of the Turing machine, the Universal Turing Machine. The UTM was simply a title given to Turing machines that were powerful enough to mimic any other Turing machine. By reading one machine's table of behavior, another Turing machine would be able to learn and implement the same exact behavior. Just like how every Apple device uses the same software system to run its program. Turing introduced the idea of multiple computers sharing the same software system without having to single-handedly code each device from scratch. Creating one of the earliest models of a computer program, Turing laid the foundations for modern computer science. Revisiting his ideas of the Turing machine, Turing presented a new design in 1946, the automatic computing engine. The National Physical Laboratory in London then built a pilot model of the ACE in 1950. It was titled Britain's New Electronic Brain and became the fastest running computer globally at that time. The pilot model ACE was later transformed into the Deuce in 1955, becoming commercially available and bringing Turing's innovation into the world. At about the same time, in 1956, Harry Huskey, one of Turing's previous colleagues, also saw the immense potential in Turing's design. He incorporated the ACE's blueprint to create the Bendix G15, the world's first personal computer, which remained in use until the 1970s. With the Turing machine, Alan Turing completely redefined the term computer and created the blueprints for the all-purpose machine that we rely on these days. Many people only remembered Alan Turing as the man who cracked the Nazi Enigma codes. However, Turing breaking the code is minuscule compared to his contributions made to computer science. Tragically, Turing was not repaid for his great contributions in his lifetime, as he was persecuted for his homosexuality and eventually committed suicide by ingesting cyanide in 1954 at only 41 years old. His last words in a letter to Norman Rutledge in 1952 were, "Turing believes machines think. Turing lies with men. Therefore, machines do not think. Yours in distress, Alan." Turing's ideas were completely hindered, and he was treated as a criminal by his very own country that he saved. At that time, people did not realize how much Turing and his ideas were already changing the world. Fortunately, in 2013, 61 years after his death, Turing received a royal pardon from the Queen, pardoning him from his convictions, and Turing is now being commemorated in England and on the new £50 banknote. Turing is and should be remembered as the father of modern computing. In fact, today, the highest award in computing is known as the A.M. Turing Award, granted annually to significant contributors to the advancement of computer science by the Association for Computing Machinery.